Okay, let's talk about the topics, the weighting on the topics for the AP Computer Science A exam. You will notice over here on the left, check mark, the weighting for the multiple choice. In order for me to get a accurate weighting for you on the free response over here on the right, I had to make some adjustments because they have the weighting displayed with the free response being half of the exam. And we want to change, we want you to see the real weighting of the FRQ based on 100%. So we've made some adjustments over here so that you can see what 100% of the FRQ weighting looks like. And then over here on the left, you can see what 100% of the multiple choice weighting looks like, treating them both as individual exams. So let's take the multiple choice section first. If we treat the multiple choice section, as an exam in and of itself, 100% of the questions, let's look to see where we can get a good bargain in terms of what to study. If you look at units 3 and 4, we have the two largest weightings, 17.5 and 22.5, which will come out to about what? 40% maximum of the exam. All right, got a 40 here. And it is of no coincidence that these two topics are going to be together anyway, because these two topics make up what I consider to be semi-complex to complex looping situations. You need the if statements in order to write some really good looping situations. Next, we have down here a little further, we have three that we can group together because what they have in common, along with being some of the next heaviest weighting on the exam, what they have in common is that they are all data structures. So you can see we can get a maximum of 25 plus that's 32.5%, about 33% maximum coverage from these three topics. So to me, for the multiple choice, rather large targets and a great way to spend your time. Now let's go over on the right. Let's talk about the FRQ. For the FRQ, we have, again, these two we can group. There's going to be a double payoff on the there's going to be a double payoff on the data structures. We would group the arrays, which will be 50% of the weighting of the FRQ, right? And in terms of matching what we're doing on the multiple choice side, if we take methods and control structures, with control structures being able to overlap from our multiple choice side, we see that we get another payoff by studying loops and conditional statements. We get another payoff on the FRQ side, right, of another 25% over here. So you can see the topics that are going to require some heavy lifting on your part in terms of your knowledge base. And you can see that you can put together a strategy, if you don't have one. Now, my highest recommendation is still for you to put together something customized for you. My highest recommendation is to go through the curriculum page by page, topic by topic, and self-identify on what your weaknesses are. That's still my highest recommendation, because I do not feel that any study regimen is going to be able to compete with what, if you're honest with yourself and you have knowledge of what you know and what you don't know, and you're willing to be honest about that. I don't think that you can put together a better set of topics than going through the curriculum, going through all of the topics, and jotting down what you want to revisit. In the absence, right, for those of you who are not used to being able to put together something like that for yourself, I would go this route. Okay, I would go data structures, and I would go semi-complex to complex loop scenarios. And these looping scenarios should contain conditional statements, whenever possible, right? That's why we say semi-complex to complex uh, looping scenarios, right? Will get you these topics will take you far, far, far into the exam. Okay, so on the left we have 4 data structures, right? You need to be able to traverse data structures. You need to be competent traversing data structures using all of the loops for AP, with the while loop being probably the least desired. So for basic for and for each loop, I'd say masterization of traversing loops. The while loop, not so much. Being able to compare index positions within data structures, knowing that primitive data types are going to be compared differently than strings, absolutely essential. The comparative method, the equals method, of extreme importance. Being able to determine your landmarks, minimum, maximum, sum, average, all of those types of things should be things that you can think through using any of the data structures. And then we have the popular data structure methods, such as length for the array, size for the array list, split, really any common data structure method, right, should be in your toolbox. And lastly, of course, knowing the difference between the 4 data structures, use case, and use case in terms of writing code, and use case in terms of analyzing code. Now on the right we have semi-complex and complex looping scenarios. What you want to look for, the EI max type of rigor in terms of how they present looping scenarios. Also, you can look back through, of course, quizzes and exams that you've taken. But you want to look for hard, or what would be considered, by a new person, new to programming, something that looks difficult to evaluate. You want to be all over that stuff. If you want to master your conditional statements, okay, master your 3 logical operators, including how to read and write Boolean expressions, Boolean statements. I think that should be a capital B, forgive me. Of course, you need to know the use cases for your while loop, your for loop, and your for each loop. And then I put nested loop in a separate category. I think a lot of attention should be paid to nested loops. I feel as though if you can read, some semi-complex nested loops, then you probably are going to, already have a good, finger on reading, any of the other three basic loops. And last but not least, for semi-complex and complex looping scenarios, and when I say semi-complex and complex, I mean looping scenarios that involve, nested loops or combinations of loops and conditional statements within. Okay. Now, my highest recommendation for solving or analyzing semi-complex to complex looping situations is an offloading strategy. That is something that I am coining. You want to offload some of the responsibility off of your brain onto paper. If you're tracking a semi-complex to complex looping scenario, uh, you need to make a simple T-chart so that you can track the state of the data as you go through each loop iteration on paper. You're already probably having to concentrate on uh, what's happening within the loop. You should not be at the same time trying to keep track of which iteration you're on and the state of all of the changes. That is way too much, and they know it. The test writers know it. You need to offload some of this. The easiest part to offload is to be able to track certain data as you go through each iteration of the loop using a T-chart. I'm going to do a really short but sweet separate video on how to put together a very, very fast and efficient offloading strategy for reading semi-complex to complex looping scenarios, analyzing those situations. So again, there are, other topics of great importance on the exam. They cannot be ignored. This is stuff that you can go after. The stuff that I describe in this video, stuff that you can go after after you have full exposure to the entire curriculum. I can't recommend it for someone who's stopping the course short, to study. I can't, because you can go after this heavy lifting and you can still leave 20 to 30% of the topics, on the board by not finishing the course. So I think that's a no-no. I think this is for someone who has finished all of the topics and they're looking to maximize, 10 to 14 days they have before the exam. And of course, you know, feel free to add to these basic skills. This by no means is an exhaustive list. This is just a good list. You can add many, many basic skills, under both categories, and you should. I hope this helps.